three currents L1, L2 and L3 in ambers flowing in a circuit satisfy the simultaneous equations 6L1 plus 2L2 minus 3L3 equals to 1, 2L1 plus 3L2 plus 6L3 equals to 1, and then we have 3L1 minus 6L2 plus 2L3 equals to 2. They want us to use the inverse matrix method to solve the equations. 13 marks. Six L1 plus 2L2 minus 3L3 equals to 1, 2L1 plus 3L2 plus 6L3 equals to 1, 3L1 minus 6L2 plus 2L3 equals to 2. Okay, so these are the three simultaneous equations. Now we shall let x equals to L1, y equals to L2, and z equals to L3. Therefore, the three equation becomes 6x plus 2y minus 3z equals to 1. Then the second equation will be 2x plus 3y plus 6z equals to 1. Then the third equation, 3x minus 6y plus 2z equals to 2. Now we can write these equations in matrix form. So here we shall extract the coefficients of this, of x, y, and z. So we have 6, here we have 2, here we have negative 3, here we have 2, 3, 6, then here we have 3, negative 6, then 2, then of course we have x, y, z. This one equals to 1, 2, 1, 1, then 2. So this equation is now in matrix mode. We have expressed the three equations in matrix form. Now from here we shall let this matrix equal to A. We let this matrix equal to A. So once we write like that, then we can find the determinant of matrix A. So we now find determinant of matrix A. So determinant of this matrix, of course, we shall start with the 6 into, we get the minus of 6 will be 3, 6, negative 6, 2, 3, 6, negative 6, and then 2, this is 2, then minus, add with this 2 into it. Now when you take this, we shall block this column and this row, so we have 2, 6, 3, 2, 2, 6, 3, 2. Then of course we shall have the signs alternates, positive, negative, positive. So it will be plus, but it's already negative, so it will be plus, plus minus 3 into. Now we block this column and this row, so we have 2, 3, 2, 3, then 3, negative 6. You can now expand the determinants. So we have 6 into, now be 2 times 3, which is 6, minus negative 6 times 6, minus that 6. Then we have minus 2 into 2 times 2, we have 4, minus 3 times 6, it will be 18. Then this will be minus 3 into negative 6 times 2, negative 12, minus 3 times 3, 9. So this equals to, so 6 minus that 6 is the same as 6 plus that 6. So we have 6 times 42. Then we have 4 minus 18, we get negative 14 times negative 2, so it will be plus 28. Then here we have negative 12 minus 9, we get negative 21. Negative 21 times negative 3, we have plus 63. So this is 6 times 42. We have 6 times 2, we have 12. Carry 1. This is 2, 5, 252 plus 28 plus 63. Can add and see. We have 252 plus 28 plus 63. So 343. So this equals to 343. So we are saying, therefore, determinant of A equals to 343. Now after getting the determinant of this matrix, then we get the matrix C of cofactors. Let matrix C of cofactors equals to A11, A12, A13, A21, A22, A23, A31, A32, A3, 3. This is a matrix of cofactors. So we need to find the value of all these elements of this matrix of cofactors. Now A11 will be equal to. Now for us to get this matrix for cofactors, we shall use this matrix. We need to determine the minor of element 6 plus its place sign. Remember A11 corresponds to 6. A12 corresponds to 2. So we shall use this matrix to get the matrix of cofactors. Therefore, this A11 corresponds to 6. The place sign of 6 is positive. You write positive. Then the minor of this element 6 is 3, 6, negative 6, 2. So we have 3, 6, negative 6, then 2. This equals to plus into 2 times 3, that is 6, minus negative 6 times 6 minus that 6, which equals to this plus, then 6 minus minus, so it will be plus, so this is 40. Therefore, we are saying A11 or this element A11 is 42. Then you can get element A12. A12 will be equal to, now A12 corresponds to element 2. So the place sign of element 2 is now negative. Remember we started with positive, negative, so it alternates. So the first one is always positive, then this one. The place sign of element 2 is negative. So the place sign is negative. But what are the minors of element 2? We block this column and this row. So the minors of element will be 2, 3, 3, 2. So we have 2, 6, 3, 2. Like that. So this equals to minus 3 times 2 times 2, we have 4, minus 3 times 6, we have 18. So this equals to minus 4 minus 18, we have minus 14. Minus and minus be positive, so this equals to 14. So we have the value for this element. So we move on to the last element in that row. So it will be, it's A13. So this element A13 corresponds to this element negative 3. But what is the place sign of this element 3? We have positive, negative, positive, so it will be positive like that. But what are the minors of this element? We block this row and this column, so we have 2, 3, 3, negative 6. We have 2, 3, 3, negative 6. So this equals to plus, then we have into negative 6 times 2, we have negative 12, minus 3 times 3, it's 9, so this equals to, so we have negative 12 minus 9, so this will be negative 21, so plus, so it will be negative 21. So we have the element of that first first row. Then we can now come to the second row. So we have A21. So A21 corresponds to element 2. So we have positive. This element we have 6, which is positive, negative. So the minus of element 2 shall block this row and this column. So the minus will be 2, negative 3. So the place sign is negative. The minus of this element 2 shall have 2, negative 3. 2, negative 3. Then you have negative 6, 2, negative 6. Then 2. So this equals to minus into 2 times 2, we have 4, minus negative 6 times negative 3, we have 18, which equals to minus into minus 14, which equals to positive 14. We are through with this element. We move on to the element 2. A22 equals to, so this element A22 corresponds to this element 3. So the place sign of element 3, positive, negative, positive. So it will be, the place sign is positive. But what are the minus of this element? We block this row and this column. This row and this column. So we have 6, negative 3. 6, negative 3. Then we have 3, 2. 3, 3, and then 2. So this equals plus into 6 times 2, we have 12, minus 3 times negative 3 minus 9. This equals to, this will be 20, 21. We move on to the last element in this row, which is A23. A23 equals to, so this A23 corresponds to this element 6. So the place sign positive, negative, positive, negative. So the place sign is negative. But whether the minus of this element 6, we block this column and this row, so it will be 6, 2, 6, 2, and then 3, negative 6. So we have the place sign is negative, so it will be negative 6 times 6, we have negative 36, minus 3 times 2, so it will be minus 6. So this equals to minus 42. We have a minus, so it will be positive. So we are through with the element of that row. We move on to the last row, which is A31. A31. So this element will correspond to element 3. The place sign of element 3, we have positive, negative, positive. So it will be positive. But the minus of this element will block this row and this column. So the minus will be 2, negative 3, and then we have 3, 6, 3, 6. So this equals to, so here you take 6 times 2, we have 12, minus 3 times negative 3, so we have minus 9. So this equals to 21. So we move on to get A32. We want to get that element. So this element 32 corresponds to element negative 6. This negative 6. So what is the place sign of this negative 6? It will be 6, which is positive, negative, positive, negative. So it will be negative, and then the minus of this element 6 will block this column and this row. So it will be 6, negative 3, 2, 6. 6, negative 3, 2, 2, 6. So this equals to minus into 6 times 6, that is that 6, minus 2 times negative 3, get minus 6. So this equals to minus 40, minus 42. Then the last element, A33 equals to, so the last element corresponds to this element 2. What is the place sign of this element 2? Positive, negative, positive, negative, positive. So it will be positive into, what are the minus of this element 2? We block that column and this row, so it's 6, 2, 3. 6, 2, then 2, 3. This equals to 3 times 6, 18, minus 2 times 2, 4. So this equals to 14. So we have the elements of this matrix C. So we are saying, therefore, matrix C will be equal to, we now collect all this. So A11 is 42, A12 is 14, A13 negative 21. So A21 is 14, 14, A22 is 21, A23 is 42, 42, and then A31 is 21, and then A32 is negative 42, and last two we have 14, like that. So this is the matrix of cofactors. Can now get the transpose of this matrix C. Transpose equals to, transpose is simply interchanging rows and column. So here we can interchange this row to become a column. So it would be 40, it would be 42, 14, negative 21. This row to become a column, it would be 14, 21, 42. Then this one will be 21, negative 42, then 14. So transposing a matrix is simply interchanging rows and column. But when you get a transpose of this matrix, which is this one, So the resulting the result of this is equals to adjoint of matrix. Remember the matrix is this one. So when you transpose this matrix, then you get adjoint A. Then we know that inverse of matrix A is given by 1 over determinant times adjoint of matrix A. 1 over the determinant times adjoint of matrix A. Therefore, this equals to, remember the determinant was 343. Therefore, this will be 1 out of 343 times the adjoint of A, which is this one, so times into 42, 14, 21, 14, 21, negative 42, negative 21, 42, 14. So this is now the inverse of this matrix. Now, after getting the inverse of this matrix, we multiply both sides of this equation. We shall multiply here with the inverse of this matrix and also multiply on this side. And the reason why we multiply with the inverse of this matrix is to get a unit matrix here, so that when you multiply with the x, y, z, you remain the x, y, z on this side. So let us see. Now how this. So we pre-multiply. So on this side we have 1 all over 343 into 3, so it is 42, 14, negative 21, 14, 21, 42, 21, negative 42, then 14. Remember we have pre-multiplied, so we get the matrix A, which is now 6. 2, negative 3, 2, 3, 6, 3, negative 6, then 2, then 2, then we have x, y, z equals to, remember we are pre-multiplying, it will be 1 all over 343, 42, 14, negative 21, 14, 21, 42, 21, negative 42, 14, then we have 1, 1, 2, like that. Now when you multiply this with this is the inverse of this matrix, so when you multiply the two, we shall be able to get a unit matrix which is given by 1, 0, 0, 0, 1, 0, 0, 1, x, y, z. Be able to get that on this side. So this equals to so we can now multiply on this side. So here you can multiply this and that, then we can divide through. So here we have 1 all over 3, 43 into 42 times 1. We have 42 plus 14 times 1, then plus 21 times 2. It will be 42. We are through that row. Then we have 14 times 1. We have 14 plus 21 times 1, which is 21. Then we have this negative 42 times 2. We have minus 84. Then negative 21 times 1, we have negative 21 plus 42 times 1, we plus 42, then plus 14 times 2, have 28. This equals to 1 all over 3, 43 into and now add 42 plus 14 plus 42. So 2 plus 4, 6, 6 plus 2, we have 8. Have 8, 4 plus 1, 5 plus 4, 9, 14 plus 21, minus 49, negative 21 plus 42 plus 28, we have 49 is equals to, now you divide through by 1, we multiply through by 1 all over 3. So this will be 90, we have 98 over 343 minus 49 all over 343, then we have 49 all over 343, like that. So this will be equal to 2 all over 7. This will be negative 1 all over 7. This is 1 all over 7. So remember this, when you multiply this unit matrix with this, you remain with x, y, z. Therefore, x equals to 2 over 7, y equals to negative 1 all over 7, z equals to positive 1 all over 7. But remember from the beginning, we had said that x equals to L1, y equals to L2, and z equals to L3. Therefore, L1 will be equal to 2 over 7, L2 negative 1 all over 7, L3 positive 1 all over 7. Thank you for watching and listening.